Hello everyone. Imagine holding a refreshing drink in your hand. Maybe it's a glass of orange juice, maybe it's vinegar-laced salad dressing, and you don't even realize you are dealing with two of the most famous organic molecules on the planet, ethanol and ethanoic acid. Both are part of our daily lives, from the fuel that runs certain cars to the kitchen ingredients that give flavor and preserve food to important industrial processes that make paints, perfumes, and medicines. Ethanol, also known as ethyl alcohol, has the formula C₂H₅OH, that's two carbons, five hydrogens, and one hydroxyl group. Ethanoic acid, commonly called acetic acid, has the formula CH₃COOH, that's two carbons, four hydrogens, and two oxygens in a carboxylic acid group. In this lesson, we are going to explore what makes these molecules special, their structures, their properties, the fascinating reactions they undergo, and most importantly, how they connect to real life. Let's start with ethanol. Structurally, it's a simple chain of two carbon atoms, each bonded to hydrogen atoms, with the last carbon attached to a hydroxyl group, that's an oxygen-hydrogen bond. Ethanol is a colorless liquid with a boiling point of about 351 Kelvin, and it mixes with water in any proportion because of strong hydrogen bonding. It's also highly volatile, meaning it evaporates easily. When it burns in air, it produces carbon dioxide and water, releasing energy with a clean blue flame. The combustion can be represented as C₂H₅OH plus 3 O2 gives to CO2 plus 3H2O. That hydroxyl group is not just decorative, it gives ethanol the ability to form esters, undergo oxidation, and participate in many organic reactions. Ethanol's uses are everywhere. In beverages, it is the key psychoactive ingredient affecting the central nervous system. In industry, ethanol is a solvent for paints, varnishes, and perfumes, and it is used as a fuel, often blended with petrol to form gasohol. It's also an effective disinfectant. In hand sanitizers, ethanol destroys microorganisms by denaturing their proteins. However, ethanol is not without risks. Consuming too much impairs judgment, slows reaction times, and in extreme amounts can cause alcohol poisoning. Long-term excessive use damages the liver and leads to a condition called alcoholism. So ethanol is a molecule that must be used wisely, a helpful friend in industry and medicine, but a dangerous one when misused. Now let's turn to ethanoic acid, the compound that makes vinegar sour and so useful in cooking. Its structure is built from two carbon atoms, three hydrogens bonded to the first carbon, and a carboxylic acid group on the second carbon. The formula is CH₃COOH. Pure ethanoic acid is a colorless liquid with a sharp smell, and it boils at about 391 Kelvin. When cooled below 290 Kelvin, it freezes into ice-like crystals, which is why pure ethanoic acid is called glacial acetic acid. It is a weak acid, meaning it only partially ionizes in water, producing hydrogen ions and acetate ions. This partial ionization is why it turns blue litmus paper red, but does not conduct electricity as strongly as a strong acid like hydrochloric acid. Both ethanol and ethanoic acid participate in important chemical reactions. First, oxidation of ethanol. In the presence of acidified potassium dichromate, ethanol is oxidized to ethanoic acid. The reaction is C₂H₅OH plus O2 gives CH₃COOH plus H2O. Second, esterification. Ethanol reacts with ethanoic acid in the presence of concentrated sulfuric acid to form ethyl ethanoate, an ester with a sweet, fruity smell, and water. The reaction is C₂H₅OH plus CH₃COOH gives CH₃COOH C₂H₅ plus H2O. Third, saponification. Ethyl ethanoate reacts with sodium hydroxide to produce ethanol and sodium ethanoate. And finally, neutralization. Ethanoic acid reacts with bases like sodium hydroxide to produce sodium ethanoate and water. Each of these reactions has real-life applications, from perfumes to soaps to food preservation. Let's solve a quick example. We are given 46 grams of ethanol reacting with ethanoic acid to produce ethyl ethanoate with 100% yield. The molar mass of ethanol is 46 grams per mole and of ethyl ethanoate is 88 grams per mole. Step 1. Calculate the moles of ethanol. That is 46 divided by 46, giving 1 mole. Step 2. From the balanced reaction, 1 mole of ethanol produces 1 mole of ethyl ethanoate. Step 3. Calculate the mass of ester formed. 1 mole multiplied by 88 grams per mole equals 88 grams. So, under complete reaction conditions, we produce 88 grams of ethyl ethanoate. So, to sum up, ethanol and ethanoic acid are two key organic molecules that connect textbook chemistry to daily life. Ethanol, C₂H₅OH, is an alcohol used in beverages, fuels, disinfectants, and industry. Ethanoic acid, CH₃COOH, is a carboxylic acid found in vinegar with applications in food, preservation, and synthesis. We explored their physical and chemical properties from boiling points and solubility to oxidation, esterification, saponification, and neutralization. Understanding these molecules helps you see the bridge between molecular structure and real-world function. I hope this session has helped you appreciate the chemistry in your surroundings. See you in the next class with another fascinating topic in organic chemistry.